So if we're solving this second problem, if it gives you 304 grams of iron 2 sulfate and enough water to make 500 milliliters of solution, what would the concentration be? I'm solving for molarity. Notice in the problem I'm not given moles, I'm giving grams of iron 2 sulfate. I'm going to have to convert that into moles. Hopefully the milliliter to liter conversion is a little bit easier for you. So if I solve that, I got to remember that number. I start off with writing what I was given, which I was given 304 grams of iron 2 sulfate. The formula for iron 2 sulfate, by the way, FeSO4. I'd want to convert to moles. To do that, I need to know the molar mass of FeSO4. Iron has a mass of 55.85. Sulfur is 32.07. Oxygen is 16, but there's 4 of them, so that's 64. I got 151.92. Put a little G in there for grams. If I take 304 divided by the 151.92, I need to have my answer expressed with at least 3 sig digs. And this one is going to turn out to be 2.00 moles. Once you have your moles in a molarity problem, you can divide by the liters. .500 milliliters is the same as 0.500 liters. One thing I would mention about this right now, and I forgot to mention when I was going over your test taking. Multiple choice on the AP Chem test is without a calculator. Most of it isn't calculation in the multiple choice, but there might be a little bit. This is a calculation right here on the board, 2 moles divided by 0.5, that you should be able to do without a calculator. We have to practice that when we start taking our tests as well. If you look at this and you're like, I don't know how I could actually solve that without a calculator. Here's what you could do. You could multiply the numerator and the denominator by the exact same number. That won't change the ratio. If I multiply the top and the bottom by 2, I picked the number 2 because 2 times 0.5 is just 1. Any number over 1 is just going to be that number. So 2 times 2 is 4.00 molar, would be my answer for that problem. When you are doing a multiple step problem, you only have to make sure the final answer has the correct number of significant digits. If you round off every step, sometimes you might be over-rounding, and that might affect your overall value. Again, WebAssign might get a little picky with that at times, so be careful when it comes to something like that. Here's the slide on diluting. Diluting is the new material I have to give you for the day. We will actually be performing dilutions in class next week. To dilute means to water down. I mean, people might have used the term dilute figuratively before. They're watering down some information. They're making it easier for you to digest. They're spreading it out a little bit more so it's not as concentrated at once. Literally in chemistry means you're adding water. Just today, I got a shipment from my vendor, and in that shipment was sulfuric acid. I buy the absolute most potent version of sulfuric acid that I can find, because then it's a small bottle, so I don't have to store it in a big space, and then I can just add water and use it for an entire year. It makes it really, really dangerous to work with, but I save the school money, and I save me space of where to store it. What I have to do to make it safe enough for students to work with is I have to mix it with water to make it a lower concentration. That equation that you see in the 4th bullet point, that is our dilution equation. M1V1 means initial molarity, initial volume. equals M2V2. Final molarity, final volume. Third bullet point says, well, if you take molarity times liters, it would equal moles. All that equation is saying is the moles that you start with equals the moles that you end with. If you add water, it's just going to spread it out more. Second bullet point, by the way, is in your safety contract. Maybe not that wording. But if you ever had to dilute a concentrated acid, you don't actually add the water to the acid. You add acid to water. Like you add acid to water. If you don't, a lot of heat can be generated enough to make that solution boil, or perhaps even make a little explosion. And you don't want acid to be boiling. Now you get bubbles of acid flying at you. That's not safe. You can give off the gaseous form of it as well. That's not good. After we get down this slide, I'll show you an example of how to solve this type of problem. And then the rest of the class, which isn't a lot, but a little bit of time, could be for you to work on either of the last two worksheets you picked up on the way in. Again, remember, we are kind of going up until the bell today, so if you don't have time to work on this and you're confused, either you can come in at a separate time or realize that this will be covered again next class. That sulfuric acid that I ordered, which, by the way, that's the formula for sulfuric acid, is 18 molar. Let's say that I want to do a lab where we need 6 molar sulfuric acid. And I know I do a lot of math at times to figure out how much do I need to make so that every student has enough. Let's say, let's keep it easy, I need 1 liter of that solution. Just like in the molarity math, when you are given an equation, you're going to be given 2 of the 3 variables. In dilution math, you'll be given 3 of the 4 variables. And in this particular one, if the initial volume was 18 molar, I want to solve for V1. How much of that do I need to make to equal 6 molar, that's 1 liter? This would be, hopefully, a fairly simple dilution problem, where if I were to solve for V1, I would divide both sides by 18. 6 divided by 18, well, 6 over 18 is a third, right? We okay with that math? 2 sig digs, I'm going to call it 0.33 liters. I mean, I could call it 330 milliliters, as long as I didn't use a decimal after the 0. Most people, when I show them an equation like this, and they know, hey, there's 3 variables, I solve for the 4th, they have no problem doing the math. The tricky part is, what in the world does this even mean? What this means is I'm going to take the stuff that's really concentrated. I'm going to take 330 milliliters of it. I'm going to mix it with water to get to 1 liter. And if I do that, I just made 6 molar sulfuric acid. I did dilution freshman year in the dorms. Instead of going down to the cafeteria to have breakfast every morning, I had some milk in my little mini fridge and I had cereal. So every morning I'd have cereal for breakfast. I would buy, I think I'd buy whole milk. And as I started using the whole milk and that volume went down, I wanted to stretch it out a little bit longer. I didn't want to have to buy more milk. So I'd add water to it. And you might think that's kind of disgusting, but I can make whole milk turn into 2% milk then by just adding some water. I'm diluting it. Mix it around a little bit, pour it on your cereal. Oh, there you go, good. Also, when it gets down a little bit more, I added more water. I made my 2% down to 1%. Mix it around, pour a cereal, okay, that's good. Usually I would stop before it turned into skim milk, because skim milk is disgusting. Okay, skim milk is making water taste bad. I'd just rather have water if I could. But in a dilution, your 1s are your concentrated stuff. What's the molarity of the potent stuff? How much do I need? Your 2s are what's the final molarity, what's the final volume? And if you're thinking about this afterwards, when I solve for V1 here, that's the volume that I need of the potent stuff. How do I get to 1 liter if I only have 0.33 liters? I add water. You water it down. Again, next class, in the class period afterwards, we will be doing dilutions in class.